Hello and welcome. This is Sam, and we're part of the Level Up Africa program. Today, we're going to be talking about Unity Dots, which is a hot topic that has been around since maybe 2017 or 18. We have a special guest today who I'll introduce who knows way more about it than me. We're going to step through talking about how dots can be integrated with other non-dot systems, so that there's lots of different reasons you might want to do that, and we'll explore that. We'll also show a complete game that was done without dots and with dots, and all that source code will be available to you, link below. So in this talk, Unity, as we know, everyone on this channel, that Unity is a versatile game engine and it's used in so many of today's popular games. Dots is a new optional way that within a Unity project, you can create even more ambitious games. So Dots is not just a feature that you add in, it's really a way to rethink about how you organize your project. So in thinking about how Dots and its architecture so heavily influence us as game devs, I also included, it was part of this talk, model, view, and controller. So Dots doesn't use that, but it's just one of the other words that's out there, another way you can structure your project. So we'll kind of compare a very basic project to one with MVC, and then one with dots. So let's talk a little bit about the introductions here for each of us. So my name is Sam. I'm a Unity game dev. I've been doing Unity for over 10 years and game dev for over 20. My mission is educating and entertaining with interactive technology. I've shipped Unity titles for all sorts of different platforms, and I'm available for remote contract hire as a Unity educator and as a Unity dev. And I'd like to introduce Johnny Thompson. Johnny, take it away.
Hey there, I'm Johnny. I'm a creator and freelance developer. I've been working in Unity actually pretty close to 10 years as well. And so for me right now, I kind of have been exploring Unity Dots quite a bit and really just want to help developers of all kinds realize their most ambitious projects. Most of the stuff that you can find for me is on my YouTube channel, which is called Turbo Makes Games. Again, I have a lot of stuff related to Unity's data-oriented technology stack and their entity component system. And we're going to be getting into what all that means in just a little bit here.
Sounds good, man. Thanks for coming. Yeah, I became aware of you because you talk so much about dots. It's such a interesting and powerful subsystem in Unity, and has been, I've been scratching my head on it as it's been maturing. So I've done a couple simple Pong type games over the years in different versions of Dots, but this year, as Dots is now 1.0, I haven't dug back into it. So I'm excited to learn from you today. Cool. So this video and this series is part of a program called Level Up Africa. So Johnny and I are both from the States, but I happen to be a digital nomad, and I've been in Africa for the last couple of years. Africa is a tremendously big game market. There's more double-digit growth of game players happening here, particularly on mobile. And there's also lots of game dev happening. So I'm currently in Nairobi, Kenya. I'm going to Tanzania next. And in both countries, there's quite a bunch of game dev education at the university level, and young professionals doing game dev too. So this is part of that series. So a brief overview of Unity. So game development as an industry is gigantic. Just the other day, I was hiking with a group of people who didn't really understand how big the industry was. And I reminded them that globally speaking, of all the movie, film, TV, books, all of that entertainment media together combined doesn't even come close to the game development's revenue per year. And it's been like that since the early 2000s. So game projects today, particularly AAA ones, have huge budgets, huge teams, and make lots of revenue. So younger people who are the target market for a lot of entertainment media are playing games more than any other leisure activity, and that is growing year over year globally. Then the revenue per continent and globally is huge as well. I'm located in Africa, as I said. So here, and plus the Middle East, we're talking about over 7 billion and growing here. And then, of course, North America, where Johnny's located, coming in at 50 to 60 billion. So the industry is huge and growing. So it's a fantastic time to learn about this technology as a hobbyist or a professional. So Unity as a choice of game development technology, it's tremendously popular. There's probably like 20 off-the-shelf engines that you could choose out there, let's say. Often Unity is compared to Unreal. Both of those are very big in the industry as ways you can learn game development and contribute to the whole industry. And Unity itself is particularly powerful in the mobile industry, with over 70% of the top 1,000 mobile games today created with Unity. And there's lots of people using the Unity technology to create games. Quite confusingly, Unity is the name of the product that you use. It's also the company, and it's also their services. But usually we're talking about the Unity editor, which is the program we'll open up today. You can do all sorts of different stuff with it, 2D, 3D, VR, AR. Today, we're just going to look at a desktop simple game. So yeah, there's even more info, but I'm going to continue on to get to the good meat of the talk. So when you're creating games as a game dev, there is all sorts of different systems and concerns that you have when you're creating something. Here in this screenshot, which you can see from a third-person action game like Fortnite, there's all sorts of different stuff indicated here. There's the user interface elements around the screen. There's taking input from the keyboard or the mouse or the controller or the fingers on a touchpad for mobile and stuff. There's rendering out audio and graphics and having your character and different elements in the game animate. And you bring it all together with scripting or code. And in the Unity world, that's done with the C# programming language. Some of the systems inside Unity are listed here, and there's a lot. So the ones that I just mentioned are kind of bold there. And you can see that DOTS, the data-oriented technology stack, is in there as a feature you can use right out of the box with Unity. There's also a trend in game dev and in Unity to have more of the elements be visual in dragging and dropping for code. So we've got visual scripting listed there alongside C# scripting. Everything we're going to take a look at today is with C#. That means you're manually typing out the code. In addition to having the features in the engine, as I mentioned, Unity has a lot of optional services. They're particularly marketing quite well around these days. So if you want to take your small project and scale it up big, you can add multiplayer, you can add backend technologies, all sorts of different ad revenue and monetization schemes. All part of Unity is there as well. All that stuff's optional. And when you're learning Unity, it's completely free to use the editor itself. So you can get started with the stuff we see today. I'll include a link for downloading Unity. So now let's talk a bit about DOTS. And I'll lead here with this thought, and then I'll hand it over to Johnny to talk about kind of what DOTS is and how it fits into the ecosystem. So here it says, every decision that we make about technology, processes, and people can be viewed as a form of investment. And these investments come with a cost, and we carry the trust, we believe in ourselves that eventually they'll pay off. I think this is particularly relevant in game dev because we're always using new systems inside of our favorite game development engines, and you never quite know when is the right time to hop onto a new version of a technology. So in today's talk, we'll talk a bit about the new Unity UI system called UI Toolkit. We'll talk about the relatively new input system called input system versus the old one was input manager. We'll also talk about architecture. And then, of course, we're talking about DOTS. In each of these cases, when Unity has kind of two or more ways to do something, you have to learn from experts like Johnny, see when is the right time to hop in. So Johnny, let's just have you take it away. Is now the right time to hop into DOTS? And please take it over.
For sure. Yeah, so just to give a quick overview about what DOTS is. So DOTS is actually an acronym. It stands for the Data-Oriented Technology Stack. So it's really a collection of a bunch of different packages that are built with data-oriented design in mind. We'll be going into that in just a little bit, but just some of the quick advantages of DOTS. High performance is really one of the main things that people kind of go to DOTS for, and being able to scale your project to much larger scales than you could have ever kind of imagined. And another really great and important part to me about data-oriented design is that it's very modular. Everything is kind of separated out into these, nice little different things that we'll talk about in a moment here. And it really just allows us to kind of, plug and play, take things in and out, being able to, swap things and try different types of implementations for different systems and everything. So it is really great. But one thing that we kind of mentioned early in the beginning that I do just want to, kind of highlight is, Dots is a little bit different than a lot of other Unity features. We kind of mentioned the UI toolkit and input system. These are just kind of features that we can say just add in to any Unity project. Now, when we're talking about Unity's data-oriented technology stack and their entity component system, it's going to be a little bit harder to just kind of add this into any project. To really get the full advantage of this, you kind of really need to learn it and experience it and figure out, how it really works to, really tune it to get the most out of your project. So we can go ahead and move on to the next slide here.
That sounds good. I'll advance the slide in a sec. I just wanted to ask about this screenshot. So I think screenshot is from when Dots was first announced. Is that around 2017 or so, I think?
Yeah, 2017 is about when they kind of started talking about, started like kind of teasing some of these new features. And yeah, this is Joachim Monte, the previous CTO of Unity, and he's showcasing this mega city demo.
And I think that a week ago I saw they've updated the mega city. I didn't look at it, but I just saw like a thumbnail or something on YouTube. Is that true?
Yeah, we actually do have a screenshot a little bit later in the presentation where they have a multiplayer version of it. So we'll be talking about that too.
All right, super cool.
Yeah, so to kind of go into sort of what the difference between, say, object-oriented programming and data-oriented design is, they're kind of different, programming paradigms. Of course, many people may be familiar with object-oriented programming because that's typically what's taught in most schools. And that's kind of what we mostly use when we're using Unity game objects, is kind of an object-oriented programming paradigm where we kind of have classes that can all inherit from each other. The one kind of major issue with object-oriented programming is it's really reference-based. So as you can see kind of in this diagram here, we have, say, these maybe game objects that have all these different things associated with them. Maybe they have, colors and positions and things of that nature. So this kind of screenshot is sort of demonstrating of how the memory layout of these things might look. And you can see that things are all kind of scattered all over into memory. And now this becomes a problem when we start, iterating across many, many numbers of these game objects. Because if we have, say, a list of all these spheres like we see at the top here, and we want to reference them, different parts of them for rendering, maybe we want to see their position and their color and all that, we have to, bounce around to different places of memory. And that actually ends up being quite costly, just because we're actually wasting CPU cycles as the computer is looking up these different things in memory and trying to actually bring those into the computer processor. Now, moving over to a data-oriented design paradigm, the thing with data-oriented design is we kind of structure our code and project in a way that is much more natural to how our computers, properly store memory and process data. So as you can see, everything is kind of aligned very nicely and contiguously in memory. The advantage that we get from that is now when we're iterating across a bunch of these different entities, they're called, we can basically just kind of go through them all in a line. And because all that memory is right next to each other, as we kind of pull in the first bit of memory into the CPU, the way that the CPU's cache works is it's going to naturally pull in, some of that data in kind of the next part of that list. So the idea is we're really, kind of optimizing for having that data, already available in our CPU cache, so we can just kind of, continually iterate through that without having to go to all different places in memory.
Sounds good. Now, it's just based on the visual differences in the diagrams, it looks like a pretty significant difference when you're moving from OOP to DoD. Does it also feel that different as a programmer?
So yeah, it is a little bit different. We're going to be getting into kind of, how we specifically structure things in just a moment here. But really the main kind of difference between, say, object-oriented programming and data-oriented design is with object-oriented programming, we treat everything as objects. Now, these objects have kind of properties about them, and they also have functionality associated with them. So, typically if we had, say, some mono behavior script, we might have some, properties about, a move speed of a particular component. And we also might kind of define some of the logic about, how that particular game object moves throughout the game world. So that would all be kind of contained within one script. The difference with data-oriented design is each, say, entity, they really kind of only have their representation of the data. So we're separating out the data from the systems, from the actual game logic for things happening in our game. So each of these entities is really only going to have data associated with it. Then we have these separate systems, and these systems are now basically going to be tuned to run on, say, groups of these entities. And again, because we can just iterate through these entities very quickly, we can say just get a list of all the game objects that are all the entities that fit a particular type, and say move those based off of the data components that we have stored on that entity.
Sounds good. You ready to move ahead here?
Yeah.
All right.
So yeah, now we can kind of go into what some of these exact packages are. Kind of the main one that is almost kind of used interchangeably sometimes with the word dots is ECS, which stands for the Entity Component System. Now, when I say Entity Component System, it is a little bit of a misnomer because Entity Component System isn't like one thing. It's not like the system of entity components. It's really representative of three different things. So entities, components, and systems. So it kind of, again, goes into that separation of data from our transformations. Again, like I was just saying, like data is going to be grouped contiguously in memory. So when we're iterating across, many ones of these, entities of a similar type, we can, again, do that very quickly. So, one of the real big use cases is when we have, say, lots of entities. In this little screenshot here, this is kind of a silly little example project that I made where I made Flappy Bird, but there's 10,000 birds.
Very cool. So each one of those little birds would be one entity?
That's correct. Yeah. In this case, so yeah, each one of those birds is one entity. Each of those birds, they have their own data components about, say, how quickly they can move, some other properties that, help them kind of separate from some of the other birds that are surrounding them. And then we have, say, systems that are going to operate on groups of these birds that are basically just going to, actually move them through the world, and apply forces to kind of move them away from nearby birds.
Very cool. All right, we'll move to the next one.
Mm-hmm. Yeah, so the other kind of big packages that we're talking about when we're talking about the data-oriented technology stack are the C# job system as well as the burst compiler. Now, these things are kind of used together a lot of times, but they can be used separately. But you really get the most benefit when you use them together. I should also point out that you can use the C# job system and the burst compiler without using Unity ECS. So you can still use the job system and burst compiler with regular game objects. There are a couple additional steps that you have to kind of go through to get them to work and really get the full kind of advantage from them. But basically, just to give you a quick overview about what these things are. So the C# job system allows for easy multi-threading in Unity. I say easy because Unity kind of takes care about, all the nitty-gritty details about, say, which threads in our CPU are available to perform work. And there's also kind of some dependency checking in there. So we're not like having two threads write to the same bit of memory where we might end up in some situations where we could get unpredictable results from. So there's a lot of kind of, safety checks in there. So actually it ends up being pretty easy for us to do multi-threading using the C# job system. And the burst compiler, again, this is typically used in conjunction with the job system, because with the job system, there are some restrictions about the, say, data types that we can use to multi-thread. The burst compiler has some of those similar restrictions. But the thing with the burst compiler is basically what it does is it takes our managed C# code and it compiles it down into native assembly. So we can actually really get the most performance out of our games because it is just compiling down into a much lower level. It also does a lot of optimizations along the way. One of the ones that it kind of does a lot are SIMD operations, which stand for single instruction, multiple data, where it basically, say, combines multiple CPU instructions down into one instruction. So rather than, say, calling one instruction 4 times, we're kind of combining all that data into one instruction. So we can just kind of, again, get much more performance boosts from it.
Awesome. And as you said, you can use jobs and burst without dots, but were these two systems created with dots in mind from the get-go?
Yeah, so there are, I should point out that when we're using them with, say, the entity component system, it's really, really easy to integrate jobs and burst. Again, when we're using them with game objects, there is still a couple extra steps that we have to do where we have to say, schedule these jobs. And then once the jobs are completed, we have to kind of synchronize the results back to the game object side. The way that ECS is built, just the way that we're kind of naturally doing things already, it's really easy for us to say, schedule a job and burst compile particular systems. And actually, just to give a quick example about, what some of these things could be used for. These could be used for costly systems and algorithms. For example, procedural generation. So you think of like a game like Minecraft, where we're doing, kind of all this random generation of these, big worlds. These systems can be quite, taxing on our computers. So it's, really important that we kind of use things like the job system or the burst compiler to, really optimize these systems so the game isn't, constantly hanging up as it's trying to generate these different worlds.
Very cool. Very cool. Yeah, I've used jobs. I never used burst. Sometimes I notice burst is in use because I'm using Unity and Unity is using burst. But I've created my own jobs for non-dots related stuff just to try it out. And yeah, it is much, much faster.
Totally. Yeah.
Cool.
Yeah. And so, yeah, there are a lot more packages that are available for dots. Netcode for entities is a really big one. The great thing about netcode for entities is it's really geared towards making competitive multiplayer games in Unity. So it allows us to do, much more high performance things, when we really need some, very accurate, simulations for our multiplayer games. And there are a lot of other advantages for netcode for entities that we could kind of get into, but that may be a little bit out of the scope of this talk. But there's also things like dots physics, havoc physics, which is kind of, based off of the regular dots physics. We have entities graphics for being able to render large numbers of entities, native collections, which again kind of work well with the C# job system and burst compiler. There also is a new math library that works very well with the burst compiler. And they do have a dots character controller package as well.
Very, very cool.
And so, yeah, just kind of talking about, who dots is for. So again, kind of, one of the main cases that people might want to use ECS is when you have games with like very high entity counts, when you want to have, say, a lot of enemies in your game, or, maybe again, you're making some game where you're making Flappy Bird with 10,000 birds, just funny things like that. Or even if you're doing more complex simulations, these don't necessarily have to be games. Maybe we're doing kind of more, science and physics-based simulations. I think it could be definitely a good option to look into. And then, of course, anytime that we're working with performance-critical devices. So if we're building games for mobile, VR, AR, Nintendo Switch, anything like that where, performance really matters on, say, a lower-end device, we can, again, use the data-oriented technology stack to really gain back some of those, performance losses that we might have otherwise.
Mm-hmm. Yeah, it's cool to imagine new types of gameplay you could have, new game mechanics when you'd have hundreds or thousands of enemies instead of just 5 or 10. So I could see that, you could come up with new types of games with those high entity counts. But moreover,
totally.
When I've worked on AAA games, for mobile, we target certain devices. Depending on what game we're going to do and how optimized we have the time to make it, we might say, okay, we're not going to target any iOS or Android devices that are more than 3 years old. Now, many people in the world are using those older devices, but just
Right.
kind of a workflow decision, we might draw a line in the sand so that we can use, graphics that are more compatible with later devices, et cetera. But I'd even imagine where a game that doesn't necessarily have tons of high entity counts, you could use dots just so that you could even have a wider audience of slightly
Yeah,
older
absolutely. Yeah.
devices, which is a really cool idea there. And then Nintendo Switch is cool too, as an option, because of the console world, it's less powered,
Right.
but it's tremendously popular. I just saw
Absolutely.
the other
Yeah.
day that it's 6 years old, and last month it sold more units than it's ever sold. So
Yeah.
imagine
Yeah.
that. That's
It's
insane.
wild.
It's
Yeah.
super popular. All right, we'll go ahead forward. All right, so I'll talk a little bit about this. So one of the thoughts I had when I was conceiving this, and Johnny and I were first talking about it, was like, okay, well, is your project 100% dots when you sit down to make a dots game? And what the little bit that of dots that I know, I understood that while dots has been in development since 2017, for example, Unity has already been using dots to replace some of its internal systems. So even if you don't know you're using the job system, et cetera, some of that technology is working under the hood for you. So you're already kind of starting to have a hybrid approach there when Unity is making their internal systems more advanced, even if you're using plain old game objects. So let's talk a little bit about, what are the benefits of dots and how you might combine them. So go ahead, and Johnny, you tell me about this.
Yeah, so kind of talking about, why we might combine entities with game objects. The main reason is because Unity ECS currently does not and probably never will have 100% feature parity with regular Unity. So there are a bunch of things like the input system, UI, sound effects, animations, particle systems, and more that don't necessarily have their direct ECS equivalent. So in those cases, we still kind of need to use game objects and existing Unity features to kind of, still have those things in our game, because those are, things that are very important to games in general. And then just, being able to say synchronize that with the ECS side, so we can kind of have our ECS for kind of our more complex and costly calculations and everything like that, and then kind of synchronize that with maybe some of the effects or other things that we might to add in that don't quite have their ECS equivalent yet.
Yeah, of the systems that are not yet ECS, is there one that would just make your life easier if one of them was to be the next to convert over?
Probably the next one, and the one that they're actively working on right now, is the animation system. Right now, ECS doesn't have any kind of like native animations. There are some third-party packages that do seem to work pretty well, but just having Unity's kind of native out-of-the-box solution for animations would be extremely helpful to have.
Very cool.
Yeah, so then just kind of talking about, how we might actually go ahead and link game objects with entities. So typically we're going to use just our regular Unity mono behaviors for our Unity features that don't necessarily have their ECS substitute yet. And there are a couple ways that we can kind of make the ECS side talk to the game object side. And that's kind of the way that we need to think about it, is like the ECS side is kind of separate from the game object side. I kind of mentioned that dots has its own physics system. So those, physics objects and colliders, they would not be able to collide with anything that uses just a regular Unity game object, physics rigid body or anything like that. So we kind of do have to think of these as like kind of separate worlds almost. And, any kind of time that we're like, communicating data back and forth, we need to kind of, figure out how we want to do that. So one option that we can do is we can have some things on the mono behavior side, say listen for events that can be invoked by ECS systems. So this is actually how I do the integrate it with UI Toolkit, which we'll be talking about a little bit later, where I kind of have an ECS system that is like tracking that data about, when we need to update UI. When I do that, I can just invoke an event. I pass along the relevant UI, and then I have the mono behavior basically listen for that event, when that event is received, then it actually updates that front end UI. There are, different ways that we could, approach this. So maybe we have, say, our mono behavior on the front end using something called the entity manager to basically just continuously read data on the ECS side. So this might be a little bit more appropriate for, say, something that's, constantly updating. So we're not like, always firing events back and forth. We just have, say, our mono behavior just always reading what that entity data is. And then further, we can kind of still pass things back from the game object side to the ECS side, again, just by using this entity manager, which allows us to kind of do some entity operations and modify entity data.
Very cool. So just recapping a bit, what I'm learning here is that, dots is a newer way to think about your project, and it comes with a lot of benefits, including speed of execution, being able to do more interesting things, more volume of entities, but also run a game on an older device, perhaps, because it's more efficient. But you can't have 100% dots project for most practical games, because a lot of the systems you're going to rely on aren't yet, or maybe never will be, in dots. So it's always important to do a blend of dots where it's important and game objects where where you can't use dots yet. So that's how the linking comes together. Does that sound right? That I'm kind of following along?
Yeah, totally. And I think that that's a very good thing personally, that we are able to fairly easily make that connection between the two, just because, now that we have these new high performance features of dots, they can kind of build off of the existing Unity features that have been in development for decades at this point. So we don't kind of, lose all that.
Very cool. All right, so let's talk about a couple of the different subsystems where this hybrid approach becomes important. I think one of the ones that is covered when we open up the Unity editor and take a look at some dots code will be how dots can work together with UI Toolkit. And then another one will be using the input system. So we'll talk about a couple of those. So UI Toolkit is something that I'm particularly passionate about here this year, as it's become available in 1.0 for Unity for uses of both runtime UI and editor UI. So UI Toolkit is a competing system to Unity UI, which is the current most popular UI solution that's probably been around for, 7 or 8 years. If you were to look for a YouTube video or find a tutorial about doing UI in Unity, that's probably a Unity UI tutorial. However, Unity's UI Toolkit is the new system. And I've noticed recently, I don't know which Unity version it is, but this is now included by default. And you have to go to the package manager to notice the old Unity UI system as is a kind of an add-on. That gives me an idea that probably this is being prepared to be the de facto system. But there's a lot of legacy learning materials and third-party solutions out there that rely on the old. But some of the really nice things about the UI Toolkit system, this screenshot here is from one of the free demos that Unity provides for learning about it, is this system is prepared for maximum performance and reusability in your game. And it's also borrowing from the web standards technology of separating your layout. Something like HTML is now available to us inside Unity. It's not HTML, but it's a layout engine. Then there's something like CSS for doing your styling. It's a Unity specific one called USS. And then you can do your behavior as kind of the third tier. So UI Toolkit, while it's a fantastic new system, it's just an example of one of the Unity systems that is not made with dots. So when we think about a hybrid approach here, Johnny, what are some things that we need to think about?
Yeah, so just kind of expanding off of a little bit about, what I was mentioning about, how we can kind of link, say, things on the ECS side with the game object side. Here's kind of an example of that. So for the way that I created this, little demo project that we'll be showing in a little bit here is I have just a regular mono behavior for the UI controller. Now that mono behavior basically keeps reference for all the specific UI elements, anything that I need to update on the UI. And again, that's kind of going to subscribe to these events on my ECS system. I can easily just get a reference to that ECS system through some kind of built-in functionality that Unity provides. Again, I'm kind of listening for those events. And then when the data is actually changed on the ECS side, that ECS system is going to invoke that event, again, passing along that relevant data. And then the UI controller is going to update the individual UI elements, just kind of based off of how I have that defined in the mono behavior.
Very cool. So this next part of the talk is how a non-dots project can be organized. So if you're new to Unity or you've spent some time doing your very first projects, you've probably been wondering about how to keep your project organized with the code so that as it becomes a bit more complex and you add more features, you don't get into a situation where the code is like spaghetti, all falling over itself and quite confused. So here in this table, I stepped through like 4 different solutions that I find as a beginning Unity game developer, how you typically architect or plan to lay out your code. So let's start with what I call the no architecture approach. So when I was first doing research about how to create scalable architectures in Unity, I created a simple 3D bowling game, like we can see in the screenshot here. And I started with it probably a couple years into my Unity experience. So the no architecture approach is where you put code in the most obvious spot. This is probably what most first year Unity devs do. You put bowling ball pin code on the bowling ball pins. You put bowling ball code on the bowling ball itself. If there's any code you need for like the floor beneath it all, you'd put it on that. It's a very nice way to start because it's intuitive. The code and functionality for something is right next to the graphics of it. The problem with that is that you see that communicating between the pin and the ball in this case becomes a little challenging. You're never quite sure which one should be responsible for what. Then I find game developers who've maybe done a simple project or two. The next idea is to have like an empty game object sitting in the scene. And that one has the biggest mono behavior and takes references to the bowling ball pin and the floor, etc. And it's kind of the manager that sits separate from the visual elements and orchestrates things together. I find that that's a pretty good approach too, but it has some scalability issues, particularly how to kind of wake up and create each of the different elements in the world. Certainly it's solvable, and I'd say a lot of hobbyist devs sit in that empty game object or empty manager type approach. The empty there, I'm just referring to it's not a graphical element. Then when you're working on a team with several people and it begins to be more difficult to coordinate your efforts together, often teams work with a custom architecture. They'll have some seniors on the team, or perhaps one senior who is familiar with design principles and design patterns and the fundamentals of software, how best practices to keep a project organized. They'll kind of lay down how the first 5, 10, 15 classes for the game should work. And then as you scale up the amount of team on there, there's some education to following the established architecture there. I'd say of 5 or so AAA games that I've worked on for projects that shipped, they're all doing some sort of a custom architecture. Now, outside of games, there's a lot of established architectures, ones that you could get from the community, freely available on Git, for example, bring them into your project, and basically take a very mature approach by using something that's off the shelf like that. It's also nice because when you're hiring or bringing someone onto your project, you can talk openly about that community-based solution and say, oh, are you familiar with that? So would you want to come on and join the team? So it's a bit less flexible to get started, but it does help when you're bringing on people if they're familiar with it. So I'll talk a little bit about MVC, but just in this established architecture, none of this part of the talk here is about dots specifically. But Johnny, I'd imagine that as teams start to use dots on more and more projects, kind of like the established architecture explanation I just gave, you need to hire people that are familiar with that technology if you want them to hit the ground running, because dots is so different. Do you feel like that's true?
Yeah, I would say definitely a couple quick points on that actually. One thing that I think I probably should have mentioned earlier on is that when we talk about ECS, the entity component system, that's not necessarily a Unity specific thing. We can have entity component systems as kind of an established architecture that people kind of have been using. It typically is most used for games. But just kind of the idea of an entity component system in general isn't a Unity specific thing. Now, Unity has a very specific implementation of the entity component system, which is kind of what we've been talking about. And that's where, yeah, it does get a little bit challenging about, say, bringing new people onto the project. I feel like right now, just because ECS or Unity ECS is so new, that you can't really expect to find many people to hire that have deep familiar knowledge with this. So it is probably something that they are going to have to kind of learn and get trained up on. And I think some of the difficulties with learning ECS become, well, number one, I think you need to have like a really just kind of deep understanding about how computers store and process data anyways. Just because, if we're kind of optimizing for that, we really need to know, how the computer is doing that so we can kind of make the correct decisions in our overall architecture. Then comes that we need to kind of like implement these data-oriented design paradigms. And that could be kind of a big shift for people who maybe have been traditionally using a lot of object-oriented programming in the past, just kind of shifting to that data-oriented mindset. And then finally, yeah, you do have to learn Unity ECS specific things, and the API can be very different than just kind of regular Unity. So it is almost like you're learning a new language. You have to learn, all these new API syntaxes, and just kind of, there are a bunch of different quirks and nuances about how Unity ECS is set up that you kind of have to learn. So it is almost like close to like learning a new language in that sense.
Wow. Yeah, I mean, some of what you're talking about reminds me of like VR development in Unity or in general. It's a new area of game and software development that in its infancy, when Oculus and PlayStation VR 1 first launched and more game teams were making content for those platforms, you couldn't expect to hire developers that have that skill.
Right.
But now that we're 6-7 years on, if you're a team working on an attractive project and you have your pick of the developer pool out there, you can try to hire first people who have that experience, since that technology's been out for a while. And then maybe part of their job is to train up juniors, because you're understanding that this niche is pretty new and fresh. So maybe we'll see something similar with Dots as more projects are done with Dots. People who have expertise growing starting from now, as it's a 1.0 product, will really be in a good position to lead teams in 2 years and 5 years and 10 years.
Yeah, for sure.
Cool. So one of the things that I wanted to talk about today was kind of the MVC approach to gaming. But I think out of respect for how big of the topic Dots is, I'll go a bit quickly through this. And then when we get to the code section, I'll focus on the non-Dots version and the Dots version, because I'm just getting how much interesting things there is to talk about Dots. It'll give us a little bit more to talk about there. So I'll go quite quickly through the next couple of slides. So as I mentioned, different architectural approaches, one of the last ones in the table was pulling an established solution off the shelf. So model, view, and controller has been around for 40 years in software. It's used quite widely outside of games. And here and there, game teams decide to use it. There's lots of other solutions like it that are mature and that could be ones you choose: model, view, presenter, model, view, view model, lots of different things. But what they have in common is thinking about your project's code base and separating out, how is this piece of code going to be used? So let me treat it separately and distinctly. So the paradigm with MVC, and then when we get to Dots, we can draw any parallels there about what separate areas Dots has, perhaps that entity, component, and system part. But with MVC, the model holds the data, and a best practice is not really to have it do anything or be too smart about where it fits into the software, but just have it be dumb and hold the data. The view is almost as dumb and just renders things out to the user, audio and graphics, takes input back from the user, so another responsibility to view. And the controller sits in the middle of those two and is able to coordinate. Now, as a beginning Unity developer, you'd probably have one mono behavior that does all three of these things. And one of the reasons that we do that is because the mono behavior base class, it confounds these three, it combines these three already anyway. If you think about a mono behavior, it has properties on it, it has methodology and functionality, it has ways to render and take input from the user just baked into the mono behavior itself, doing things like the on GUI, enable the rendering out to view and stuff like that. So when we begin to scale up our project and mature our own expertise, we can see some benefits. If we start separating the code out, it will be able to scale better over time. So some of the other benefits here about, I'll just focus on the benefits portion. If you choose an off-the-shelf solution, it's proven. You know, you and your team don't have to find all the mistakes for how architecture is set up. That's been done for you by the fact that it's an existing piece of software solution. It's also nice when you can choose something that's language agnostic, meaning it doesn't just work in C# for Unity, it works in other platforms. You can find good learning resources. It becomes part of the university education system when it's been around and applied to various different platforms. It also becomes more testable because when you choose something that's off the shelf, has that good code separation, you're able to test each of the units a bit more easily than if they were combined into one mono behavior. And all of this leads to faster development and maintenance. So just from the benefits portion, I know here we're talking about MVC, which doesn't directly tie to dots, but I'd imagine these benefits bullet points here are also something that we could look at when we're thinking about dots. You've said that ECS is something that exists outside of Unity, so we're able to borrow kind of working off the shoulders of those giants by using dots inside Unity. What do you think about that?
Yeah, totally. In fact, I actually have a book right here. It's Data-Oriented Design, classic book there. Definitely would recommend that one. And it has absolutely nothing to do with Unity, but it is just kind of talking about some of these data-oriented design principles. And I know that this book in particular was something that, you know, heavily influenced the architecture of Unity Dots as they were building it out.
Very cool. Very cool. So that's a perfect example of, you know, something that a technology that lived before Unity ever did might live far into the future, but Unity weaves that in rather than reinventing the wheel. They're looking at a real, practical, proven solution and then making it work for the specific needs of Unity. So that sounds really cool.
Totally, yeah.
So I'm going to skip a couple ahead here. I do want to mention that I have a course specific for MVC in Unity. It is not dots related, but if you're looking to mature your game object awareness and how to have your game object projects be more scalable and maintainable, you can check out the link. I'll put it up in the corner and also down below. In that, I cover all sorts of different projects, from creating simple clocks to the RollABall game that we're going to look at here together and see a dots version. And I cover some of those fundamentals, the design principles, design patterns, doing UML diagramming. These are things that have been a part of software for 2 generations, let's say, and you can apply them to your Unity practices to make yourself a more impactful developer on your own projects and when you work with other team members. So when I first conceived this talk, I thought, like, maybe we could combine dots and using MVC technology together. It was one of the things that Johnny and I talked about. So Johnny, tell me some of the takeaways you think about the challenges of combining those two.
Yeah, and so I just real quickly want to point out that, you know, I don't necessarily come from a traditional MVC background, so I don't have maybe as much knowledge as you do on this. But as I was just kind of stepping through some of your sample projects in that, I noticed that, you know, MVC, you know, it kind of splits up, you know, its project, of course, like you're saying, into the model view and controller. And again, you know, with ECS, we're separating out entities, components, and systems. So we're still kind of separating things out, but we're kind of drawing those boundary lines in a little bit of a different way. So it seemed a little bit difficult to kind of combine those for some of the core gameplay systems. Maybe there is a way that we could kind of have, say, MVC working side by side with Unity ECS. But just kind of for these sample projects, it seemed a little bit difficult to kind of combine those all together into one. A couple things that I do want to point out is, like you were saying, that MVC is pretty agnostic to kind of the languages and all that. I'd say Unity ECS is very closely tied into Unity. Again, we're using a lot of very Unity specific APIs and things like that when we're integrating with that. But kind of going into some of the benefits, it does have similar benefits to MVC in the sense that, because we are separating out our data from our game logic, we can kind of test individual systems at a time. And another thing that I do kind of want to mention around, we're talking about data-oriented design, we're really thinking of data as kind of the most important thing. So when we're kind of thinking about any systems, about how we want things to interact in our game, of course, it's really important to just kind of consider our data. We can just kind of think about, what is the input data that I already have? What is the output data that I want? And then how do I kind of get from point A to point B? And that kind of transformation in the middle, that's kind of what our system is. So again, we're kind of just drawing those boundary lines in a little bit of a different way between MVC and ECS.
Very cool. And, you just mentioned a couple similarities in how MVC and DOTS or ECS are kind of separated in the concerns. So I just wanted to reiterate that while there are some similarities we can see, it's not that DOTS was based on MVC or MVC was based on DOTS. I think it would be fair to say that both of those systems are just based on software principles that have been proven to work. Totally, separating your coding concerns into different areas and having your code be more modular and simply focus on one thing makes it much more easy to scale in a larger project. So
absolutely,
very cool. So now let's take a look at the stuff in action. I'm gonna talk about the 3 sample scenes and then we'll dive in. I'll open up the Unity editor and we'll take a look at the sample project that is linked below, which you can check out. And what we're building in the sample project is a simple version of this RollABall game. So I'll play it inside the editor, but we're simply the checkered ball there. It takes the WASD or arrow keys to move around, and you collect those yellow cubes. This is based on several different existing older games, but I was particularly inspired by Unity themselves has on their Learn website a version of this game. So I've incorporated it into a few different technologies. So we'll take a look first at the basic version. In the basic version, we can see a little snapshot there of the folder structure. It's just 4 or 5 classes. Each of them extend mono behavior. This is kind of maybe the empty go approach from that ordering of as you mature as a developer, how do you think about your projects? So we have the RollABall example class that is kind of the one manager to rule them all. And it has references to those yellow pickups and the player itself, and then the UI. Then we'll move on and I'll show, perhaps briefly, the same exact game, but organized using the mini MVCS framework. So that's model, view, controller, and then there's a service layer. The service layer is used in the MVC world anytime your game needs to load any external data, be it loading from disk or calling backend services, etc. So you can see in the folder structure there that I've got a controller folder, a model, view, and a service one. And then the example sits outside of that. So the structure is a bit more complex, just from a quick glance. There's a bit more happening in the diagram here. But the idea for this, and I think particularly for new people coming to the MVCS, it feels a bit laborious and verbose to do your first couple features. But the more practice you have with it, the more quickly you'll develop later on. You no longer have to think deeply about where does this feature go, because the framework itself guides you that if what you're about to add is some data, it goes in the model. If what you're about to do is going to render or take some input, it goes in the view. And if it somehow glues all that together, it goes in the controller. So there's this kind of pattern, which might feel a bit rigid when you start, but eventually when you become accustomed to it, it becomes your best friend. And I imagine in dots development, for people who are new to it, it feels a bit strict in the beginning, but then that strictness starts to pay dividends. So what are your thoughts about that, Johnny?
Yeah, totally. Again, I think one of the things that I briefly mentioned was about how modular data-oriented design can be, and I think really that just is because we have that separation of the data from the systems. So any entity that has any particular data components on them, we can say just remove those data components, add some new data components on, which really actually ends up changing the functionality, because our systems are going to operate on entities with specific data component types. So then if we say, remove some data components and put other data components on, it actually changes what systems are operating on that entity. Yeah, it is quite flexible and modular in that way when we start getting a little bit deeper into ECS programming.
Yeah, so that makes me think about something. Let me say a few things and then I have a question for you. So with object-oriented programming, like as a mentor at a school now, I'm regularly teaching people the fundamentals of OOP. We're doing it in the Unity context, but OOP exists in many, many programming languages and different gaming platforms. So some of the buzzwords that are usually come along with that conversation are having classes and interfaces, encapsulating your code so that it kind of becomes a black box and you control what is going to be private, what is going to be public. But you think of each object as a self-contained unit, and you try and lock it down by, let's say, using private methods and private members.
Sure, yeah.
And then, now it feels very different with dots. It feels like kind of like everything's public from the get-go. So is that a big difference that is it true to say there's no encapsulation when you're approaching dots?
I guess there's a couple points that I should mention kind of on that. I do think that kind of before approaching dots, it is important to have sort of a fundamental understanding about object-oriented programming, because although we're not using a whole lot of inheritance and things of that nature, those things still pop up a little bit, and especially when we're integrating with existing Unity features, it's really important to kind of have that knowledge about how we do those types of things. And so, yeah, it is kind of a little bit more, advanced, and, you kind of do have to have some fundamental programming experience to, really take full advantage of dots and all that. But yeah, I guess for the most part, when we're looking into data components, and I'm sure I'll show a couple in the demo here, but yeah, most of the, variables on our components, they're all just public. And again, we're kind of having systems that sort of operate on those data components. So it's really kind of the systems that control, say, what data that we're accessing and writing to at any given time.
Now I notice, I'm not too familiar with dots, but I noticed in the folder structure here that it's like you have a sub area of the game, like let's say sound effects. And then is it true you have the entities, components, and systems related within that sound effects folder there?
So yeah, there's actually, we can kind of get into this in the demo a little bit more, but it's really just kind of the, say, components and systems that we're storing within the folder structures. The entities aren't necessarily like, we don't have to create scripts for the entities. You'll see that I do have some things called authoring components. And those authoring components are basically what we say add on to the game object in the Unity editor, which allows us to kind of configure, say, some of the default values that are going to be added to an entity when we actually enter play mode.
All right, that sounds good. So let's go ahead and jump in here. I'm going to show, again, the basic version here. I'll just show the slides, so once we jump into Unity, we can stay there. The basic version here is going to be what I feel is probably the most beginner-friendly approach. So if you download and you check out the source, you may want to start with this one just to understand the basic pieces, because the exact same game is going to be replicated in the second version here using MVCS, You'll begin to see a bit more class structure, a bit more separation here. But again, this one is also not dots. So number 1 and number 2 are not using dots. And then here, Johnny will lead when we're going through this. We'll look at the same exact game, but done with dots. So I think it'll be interesting for those watching and learning about dots to be able to see kind of the basic version of the game, kind of a maturely architected MVC approach, kind of sitting in the middle, and then dots there. And you can draw your own conclusions about what is similar to in each of them and what's very different. So let's go ahead and jump into Unity here. So let me ask you, Johnny, you're able to see that screen?
Yep, absolutely.
Great. So in the project here, if you choose to download it, there's a README file you can click on, and it gives you some helpful hints here. So this Level Up Africa project, I've used for several different videos, not just this one about dots. So in it, there's lots of cool stuff. You can see individual scenes about UI, input, audio, graphics, animation, and scripting, those fundamentals we talked about. There's a space shooter game that if you kind of want to learn building a game from, let's say, in 5 stages, there's an emptier version, then adding UI toolkit, adding shader graph, adding VFX graph, and then finally the complete game. And each of these over here click into the particular folder you want to see inside your project. And then down here, we're going to really be talking about the RollABall. Actually, let me do like this because I think my head will be in the way. So the RollABall, we've got the 3 different versions. So we've got the basic one, then we've got the one with MVCS, and then the dots. So let's take a look at each of them. And I'm not sure if we'll look at them for 5 minutes each or more or less, but certainly the dots one we could lean into and spend a little more time.
Great.
So I'll start by looking at the non-dots basic one. And I will run the game here so we can take a look. So here, the game is running. And as I use the arrow keys, it's a little bit choppy because we're doing some screen recording. But this is a very simple game where we've got a ball that rolls around. It does Unity physics collision on the balls there. The UI is supposed to say score 1, score 2, but I guess there's a bug in my code here. It's not saying it. There we go. Finally, it's updated to score 3. Then it says you win. Then we have a restart button here that allows the user to restart. And then something else interesting, if they click restart while the game's playing, I have the game pause there, which is a small detail, but it demonstrates that this game is able to like truly pause. And there's many different ways you can do that inside Unity. The famous hack of setting time.timescale to 0 is probably what you do as a beginning Unity developer, but there's some drawbacks to that. So there's a different solution done here. So as I'm playing that, Johnny, anything you want to mention about just the basic game?
No, that looks good to me.
Okay, cool. So that's that version. Now let me step through a little bit of the code. Since we're going to look at the same game 3 times, I'm just going to kind of talk high level here. So let me show about 25 lines of code here. So yeah, I'll just do this. So let me show in the scene here, the scene structure is that we've got the empty game object that has the RollABall parent class. And in it, I drag in references to the pickups. So there's a bunch of yellow pickups there, then the UI, and then the player. And it's this one main class here that tells the player what to do, tells the UI what to do, tells the pickups what to do. So it does most of the heavy lifting here. So we'll just look at that class here. So here we're extending mono behavior as the classic Unity approach is. We have some serialized fields which show up in the Unity inspector window. So I can drag in those references I just covered. In the start here, make it a little bit bigger. In the start here, we listen in on some key events from some of the subsystems. And then we use the classic Unity update here. So Unity update runs every frame. And that could be, let's say, 60 times per second, for example. And from a high level here, I say, well, if we're not currently paused and the game's not over yet, then spin those pickups and take the user input. And from the highest level, that's kind of all I wanted to cover there. Anything else that you want to chat about there, Johnny?
No, that makes sense. Again, just kind of simple introduction to the Unity RollABall.
Cool, cool. All right, so now let's jump in and look at the second demo. So just to prove that it is the same, I'm gonna click on that one and give it a play. So this is the mini MVCS version, and it uses UI Toolkit input system, the new Unity way of doing user input, and the MVC approach. But the gameplay is meant to be the same. Actually, it's not taking my arrow keys, so there might be a bug with it right now.
I think you can use the WASD for that demo.
Ah, okay, good. Maybe I didn't mimic it there. Good, perfect. I'm glad you caught that. So here I go ahead and I can pick up, and it does show score of 1, score of 2. There's also a little sound being played, but you might not get that on the video. And then number 3, and you win. And let me go ahead and just play it again and show that if I restart, yeah, the yellow dots don't move. So we're paused, and now we're unpaused. Okay, cool. Now with this one, I'll take a look at that high level outer class, but I also just wanted to talk about the folder structure here. So we saw in the screenshot earlier that here in the project, I've separated it up by concern. So the controllers go here, which is the functionality. Model goes here, which is the data being stored. The service layer is calling any external data. I think in this case, just to demonstrate how and why a service would work, I load that the value 3 is the maximum score you need to win. Now, of course, you could hard code that in C#, but it just demonstrates loading from an external file. And then in the view here, I have some visual representations of each of the different elements on the screen. So if I look at the outer class here, this one is the one mana behavior that kind of kicks off the scene. Inside, it takes some serialized references to the different pieces of the scene as well, kind of like our last demo. But it does less of the actual gameplay here. Here, the example is going to create a mini, and the mini is going to have one controller, one service, and then each of the different views. You can see those getting passed in there. So maybe I'll click in to just look at this one, and then we'll move on. So inside here, the mini, it's going to create the different elements inside the mini structure. So it creates the model, creates the service, creates the controller, and then it passes in the view. So just from a high level, you can see that things are being created purely in code, except the views. The views get passed in. That's a pretty common convention with MVC, but it's optional. And the reason that we do it here is that it's very nice to make your views extend mana behavior so that your UI can be a mana behavior that has UI elements on it, that your player can be a mana behavior that has, let's say, the being able to take input, being able to render graphics. So we're still very much using mana behavior for the views. So it's just nice to serialize them and pass them in. And then the systems here all get initialized, and then it's off to the races. I will show the controller actually. No, actually, I want to show the input view. So it's the input view down here that on its update, it's going to be loading the receiving the input from the player. So it's using Unity's new input system, but we can see a little bit of similarity between this update loop and the one we saw in the earlier demo, where it's just taking the user input and then utilizing that. So that's all I'll show for the MVC demo. Anything else you want to mention about that, Johnny?
No, that looks good to me.
Okay, cool. So let me close up this stuff here. And then let's take a look at the dots one. So if I run dots, let's just run it. And then one of the key questions that I wanted to ask is, what is a subscene and why is it organized? But first, let me just run the game so we can see.
Yeah, we can see that. Yeah, it's again basically the same thing where we kind of have some of the UI toolkit, which is able to update when we basically collect the different pickups. Again, we kind of have the game pause there once we collect them all. And of course, we can still interact with these UI events to essentially restart the scene. And yeah, you can go ahead and restart. And Yeah, again, pretty much same sample project that we had as the previous two.
All right, very cool. So what do you think would be some interesting things for us to look at as we step through the code here?
Yeah, so actually we can probably start with just, like you were mentioning with the subscene, just to kind of, walk through, what is an entity, what is a component, what is a system. So I think it would be best to just kind of start at the top where we can talk about, what are these different entities here. So actually, if you're up in the hierarchy, you'll see that I have the RollABall subscene.
Mm-hmm.
And then so there's actually a checkbox over to the right, and you can check mark that, and it basically kind of loads it in. Actually, in the hierarchy. Sorry, like actually in the.
Oh, here. Okay.
Yeah. So you'll see that, and then now you can basically expand that little drop down, and we can see that these are basically all the entities that are basically a part of the subscene. So you can see that we have the level, which is the actual level geometry. So the blue floor and the walls and all that. Then we actually have our player. And then we kind of have some of these other sort of data only entities like our input entity and our game controller. So if we just say click on the player for now. Now, if we're looking over in the inspector here, you'll see that there are kind of a lot of, regular familiar things that you'll see in regular Unity. We have a transform, just a regular kind of a mesh on it, a sphere collider, rigid body, all those sorts of things. So basically, these are not actually kind of traditional mono behaviors. Well, so they are kind of the traditional mono behaviors, the exact same components that we would use for regular game objects. The difference being, because we have this game object as part of a subscene, it's going to automatically say convert that game object into an entity at runtime. Now, what basically happens is each of these components that we're adding on to this game object, this is kind of considered an authoring component. So really, it's just kind of like a front-end authoring component that we can kind of set up some properties about, what this entity will have when it actually gets converted over into an entity. So, although we have a sphere collider on the player right now, when we actually enter play mode, it actually gets converted to, say, a dots physics collider, which is, again, different because it doesn't actually interact with any regular game object sphere colliders. And then, of course, we can also create our own custom one. So you'll see that I have this player authoring script here. And then you see that this is where I actually set the move force of basically how strong of a force is being applied to the player when we're using the arrow keys to move the player around in the world.
Okay, that's a good overview. So let me ask, is it possible to make a dots scene work without the subscene concept?
So it is, but basically in that case, you would have to use scripts to basically instantiate, entities into the ECS world. So you can't kind of use the benefits of being able to, configure things within the editor as easily.
And how do you decide here? Like if I look at this hierarchy, how did you decide which to put in the subscene and then here's something that's not in the subscene?
Yeah, good question. So anything that's kind of like that I want to be in the ECS world, those are all going to live in the subscene, because anything, again, that's in the subscene is going to be converted into the entity representation of it. So again, that's why I wanted to say the floor, the walls, and all the pickups, because these are all physics objects that we want our player to interact with. Those things all need to be entities. Otherwise, if we say had the the level geometry outside of the subscene, well, the player would just fall right through the floor, because again, those physics objects can't necessarily interact with each other. Now, talking about things outside of the subscene, that's kind of where we get into integrating with existing Unity features. So you see that, yeah, there's the UI document, which again is kind of my sort of mono behavior UI controller, which is kind of controlling and again listening for those UI events to basically update the score, the status, and all that. And then also up at the top, I have the world, and that's basically what keeps track of, the lighting and camera, and again, some other things that we don't necessarily have an ECS representation of yet.
Okay, that's a good overview. So let me ask, how I was looking at the game controller just to see if it could have a dragged reference to the UI document, which I didn't happen to see it there, but it begs the question, can the subscene reference things that are not in the subscene at code?
That's a great question. And no, you cannot. So you can't have basically cross-scene references. And that is kind of one of the sort of inconveniences is, being able to kind of sync things because you can't have that, direct serialized reference. So you kind of need to figure out some other ways to kind of make that connection.
Okay, very cool. What would you like to look at next?
So actually, if we can enter play mode one more time, I'm going to have you select the player. In the subscene, and I can kind of show you. So again, we kind of have over in the inspector here, we have kind of all our regular mono behavior. Essentially, we can consider these as authoring components. So now if you actually hit play to enter play mode, so you see that we're still seeing kind of the authoring components on here. Now, I know you pointed out earlier, there's kind of that little circle that we have next to that lock in the upper right. And if we click on that, you'll see that currently we're in the automatic authoring view right now. So again, we're kind of seeing that, easy to use, inspector where we can say update the values on this particular entity. So again, this is just kind of the authoring side of things. So if you click on runtime, we'll actually see what ECS data components are on this player. So you see that things kind of change a little bit. So now, we have, say, this like local transform and local to world. So those are kind of the, say, equivalents of a transform. So when we have that transform component, it actually gets converted into what's called a local transform. And then it's also going to add a local to world, which is like another thing that is actually what is used to render where the object is in the world and to give it the proper scale and all that. So these are kind of the actual data components that are added to the entity at runtime. And we can kind of scroll down and I'll show you that custom one that I added on for that player move force. So you see there's kind of some physics colliders, physics mass, physics velocity. Again, these are all just kind of built-in things. There should be one called player force somewhere, or move force.
There we go.
Oh, here we go. Yep. Player move force. And you'll see that the value is set to 7.5, which again is just that value that we had set on the authoring side.
Now, when I'm in a non-dots project, I'm used to being able to click play, be at runtime, and manipulate the values in the inspector. Can I still do that with the dots project?
Yep, absolutely. Yeah, there was a little bit of time where you were not actually able to update those, but yeah, you can go ahead and say if you want to update the player move force, you'll see that the kind of strength changes.
Yep.
And yep.
That's cool. Now, can I go over to the authoring one and can I edit it there, or does that?
Yep. Yeah. You can still update the authoring side, and that will basically affect it at runtime.
Okay, that's pretty cool. So this drop-down window kind of surprised me. I didn't know that was added. Do you feel like that was always the plan? Because this feels like a nice mixture where it feels, I mean, in a way, I feel like there's two systems happening at the same time, and that feels a little confusing, but it is kind of easy to use. Like, what are your thoughts about this window here and the modes and stuff?
Yeah, it is, again, one of those things that you kind of need to wrap your head around a little bit. But I think once you get used to it, and you get used to it pretty quickly, kind of once you understand, the difference between, say, the authoring side and the runtime side, it is very helpful. Again, we can have that authoring side that's easy to work with, and then we can have the runtime side. And I typically use that more for debugging, just to make sure that an entity has the specific components that I think that it should, or, if the values are being updated correctly and all that.
Now, you mentioned before when we were first looking at this list here, that these will each be converted to something at runtime, right?
Correct.
Now,
Yeah.
is that true of any component, or is there only certain components that get that automatic conversion?
Yeah, that's a good question. So yeah, there's only certain ones that have that automatic conversion. Um, there are some things that maybe like for an animator that maybe we still might want to have kind of a reference to. Again, because ECS doesn't have an animation equivalent yet, there are ways that we can say reference specific managed components on the entity, but that gets a little bit more complicated. But yeah, to answer your question, no, not everything has a direct conversion. It's just kind of the primary things like transform and physics colliders and physics rigid bodies.
Cool. What else would we like to take a look at?
Yeah, so I guess we can kind of go ahead and look into, let's go ahead and actually go into that authoring component. I'll show you how that's set up. So you can just double click that player authoring. So yeah, I kind of went in, and if you want to kind of dive into this project a little bit yourself, I have just kind of like some comments about basically what this is doing here. So you'll see here that basically we're kind of defining this player authoring. You'll see that it's a mono behavior. And you see that all it is it just has one field. It's that editable field, which is called move force. And again, that's what we're directly editing in the Unity inspector on the authoring side. So again, it's kind of that move force. You'll see that I do have it set to public, and there's a reason for that. And that's because we need to basically access that in our Baker class. So you'll see that down below within the same class file here, I see that I have this player Baker. You'll see that it inherits from the Baker type, and you'll see that there is a reference to the player authoring type as well. So that is just, again, that kind of front end player authoring there. So this Baker is really what defines basically what happens to the entity that gets converted from a game object to an entity. So, we can kind of have any number of these authoring components and Bakers on a given entity if you want to say, add different components. So in this case, basically what's happening here is we first kind of need to get a reference to the outputted entity. So you see that this is where I'm kind of defining the entity player entity. And we basically just do this by saying get entity and passing in an enum for the transform usage flags. This is actually kind of a sort of newer feature that was added. So if we're say adding in the dynamic transform usage flags, this is basically just going to be, it's kind of like the default. It gives us, all the transform components that we need to, move our entity around in the world, to scale it up and down, to maybe do some parenting if we want it. Some other different options for transform usage flags, we can set the transform usage flags to none, meaning that the outputted entity actually does not have a transform component at all. So this is really helpful for things like data-only entities that don't need to live anywhere in the world, but just need to kind of calculate data. So we don't have that kind of extra, memory usage of having some of those transform components if they're, not really needed. So it is kind of nice that we can kind of, specify and get a little bit more kind of granular with that. But anyways, you'll see that basically what I'm doing here is I'm saying, adding these different components. So one thing that I want to add on to this player is a player tag. The reason for that is because in some systems, maybe I want to, only find entities with a specific tag. So if I want to say target just the player, I could say, give me all the entities that have the player tag. In this case, because we just have one player, it's just going to return us that one entity, but it's a way for us to differentiate the, this entity from other entities that don't have that tag.
Let me ask about player tag.
Yeah.
So that is just a component, and you choose to use it like a tag, right? But there isn't necessarily a data structure called tag.
Correct. So yeah, we can actually, if you want to actually just say F12 into the player tag, I can show you like what that looks like here. So you see that this is an iComponentData. iComponentData is essentially the interface that we implement for our data components. And you'll see that the kind of concept of a tag component is really just us defining a data component that does not have any fields or anything like that in it. So it's really just an empty data component.
It reminds me a bit of, typically you use interfaces and object-oriented programming to define what will be the properties and methods for something. But you can also create an interface that has no properties and methods, just so you can check if a data type happens to match or implement that interface.
Yeah. Very similar.
Marker interfaces in that concept. So it kind of reminds me of that. Okay, that's cool. So let me ask a question about this here. So here in this file, you created the player authoring and the player baker. So is that a common workflow that for each kind of new area of code, do you always add the authoring and the baker? Or are there some things that you don't really need the authoring and you do it some other way?
Basically the authoring and the baker, they're always going to be kind of one and the same. If we have an authoring component, you're going to need to have a baker to basically add those components to the outputted entity. And yeah, I don't think there's really a way that you can kind of use a baker without an authoring component.
What if I didn't want both of those? Is there a way I could just like somewhere else be adding some of these data components?
Yeah, of course you can use systems or even other mono behaviors to say, as long as you have a reference to a particular entity, you can use the entity manager or entity command buffers, which kind of get into more specific concepts about what you can do with Unity ECS. But again, you can kind of use those concepts to add data components with specific values on them. So yeah, you don't necessarily need to use the authoring and baking components to create entities and set entity data.
Cool. What else would you like to take a look at?
So yeah, then I'll just real quickly mention this last line here. So you see that here I'm actually adding a data component, but with some specific values. So what I'm doing is saying adding a component. Of course, I'm adding it to the player entity. And this is going to be of type player move force. And you'll see that the kind of underlying value of that, I'm setting that equal to the authoring.move force. So again, that's kind of referencing that front end authoring. It's getting the move force from it, and it's setting that to the value of the player move force. And so you can go ahead and click into the player move force there, and I can just showcase that data component real quick. So you see that this is, again, it's an iComponent data. You see that it's a public struct, so it's an unmanaged iComponent data. And you see that I just have one field on here, which is just a public float called value. And that's kind of a typical naming convention. You'll see that if we have data components that have just a single field, we'll call that field value, which makes a lot more sense to, when we reference this in code, we can just say, player move force dot value, because it is a little bit redundant to say, player move force dot move force. Right. So yeah, it is just kind of one of those kind of coded conventions.
Sounds good. Anything else you want to look at here?
So yeah, no, that would be it for the authoring. I think the last thing that I would just want to showcase is what a system looks like, so we can just kind of get a reference of how this is actually applied. So there is a player or a move player system. So it should be actually just right above that player authoring there.
Move player. So we were looking at player authoring here. There's correct, the player tag, which we looked at.
Yep, and we also looked at the player move force.
Yeah. So these two are the component datas.
Correct.
Okay, cool. So let's look at this move system here. Go ahead. Okay.
So yeah, there's kind of a lot of things going on here. So I'm not going to necessarily go deep into everything here. But yeah, a couple things that I will just point out. So you'll see that this is kind of how we define a system. So you'll see that it's actually a public partial struct, which I call move player system. This one implements iSystem. There are other ones called system base, and there are different reasons that we might use one over the other. Don't necessarily need to get into that now. One thing that I do want to point out is we do have this partial keyword. The reason for that is because Unity actually does some code generation on this system. So basically, we're kind of going to define some things in here, and then Unity does its own code generation to basically create a essentially more efficient version of this system. So it's really nice that we can kind of use a lot of these kind of high level C# language features, but then Unity does some code generation to basically convert it into a more efficient version of the system.
Okay, that's clear. Cool.
So you see that kind of in the onCreate, this is similar to, say, the awake method of a mono behavior. And this is kind of, again, these systems sort of have some life cycle associated with them. So in this, we're kind of, defining some things about this system. Here, one thing that I'm doing is I'm saying require for update player move input. So we didn't really go into input here, but this is a data component that I'm writing to, writing the player's input to. So whenever they're pressing, the up, down, left, or right keys, that move input is being updated with the, float to value associated with, whichever direction that they're pointing. So I just want to make sure that we're updating the system only if that player move input component exists somewhere in the ECS world, just so we can actually properly update the data based off of the move input. So going into the on update here, this is basically, again, it's going to be called every frame as long as the application is running. By the way, with these systems, we don't need to say, manually instantiate these or anything. I mean, just the mere existence of us having this system class, it's automatically going to run when Unity starts. So yeah, basically kind of what's happening here is we're kind of looking at the current player's move inputs. I'm using what's called the system API, which is just kind of a way that we can say access entity data. In this case, my player move input, this is kind of considered a singleton because there's only one of those in the world, and I'm basically just reading the value from that. Also, you'll see that I'm getting a reference to delta time. We just have to do that, in a slightly different way than we would get delta time in a regular Unity mono behavior, but it's the same functionality. It's just a way that we can kind of, normalize for frame rate. Now, the real important part of the system here is this for each loop here. And so basically what we're doing here is, we only have one player in the world, but the way that data-oriented design works is even though we have one thing, we still kind of need to treat it as a collection of things. So we're basically saying, let's iterate across all the entities that match a particular query. So you'll see that I'm kind of defining this query here with the system API.query. I don't necessarily need to get into all the specifics of what this means, but basically we're just looking for any entity that has all these sets of data components. They need a physics velocity, a physics mass, a player move force, and a player tag. So again, we know that our player has kind of all these components associated with it. So we're basically saying getting a reference to that player here. And then basically what's happening here is like inside the body of this for each, this is where we're kind of saying, actually doing the work where we're, taking our input data and kind of, applying that to our output data. So really what we're doing here is we're, just getting our players' inputs. We're going to multiply that by our move force value, multiply that by delta time to normalize for frame rate. And then you'll see that on my physics velocity, there's a kind of a built-in function called apply linear impulse, where we just kind of need to pass in a reference to the physics mass, and then we can pass in that new move input vector. And so that will actually, apply that force to that physics velocity object, which is essentially the data component that's added when we add a rigid body to the game object / entity.
It's very cool. So I got a question about this. So if, when I first saw this line, I was thinking, well, don't you know that there's only one player tag? So why do I need to query so complexly? Why can't I just say, go give me the thing with this one unique piece of data?
Right. So the reason that you need to do that, you see that the for each, this kind of does two things. So it not only queries for the player, but you'll see that I'm kind of also defining, I have the var, and this is actually a tuple. You see that it's kind of in parentheses there, where I have the velocity, mass, and move force. So when we do the system API.query, it gives us access to those data components specific for that entity.
I see. So I'm not allowed to access these unless I do that original longer query line.
So there are still other ways that you can access it, but it's kind of a convenience thing. You kind of get 2-in-1 where you basically, are querying for it. You're saying, find the entity with these specific components. And then, you're also defining these are the variables that I'm calling these to access those within the body of that for each.
Very cool. Now, if you, let's say you decided you needed one more thing inside here, one more component, you could add to the query and then add to the tuple and then be able to use one more thing, right?
Yeah.
Okay, that's cool.
Yeah.
Nice. What else would you like to look at?
I guess because we mentioned it, maybe we want to show the UI toolkit thing real quick.
Yeah, let's do that. So let's go back to the scene just to kind of orient ourselves here.
Yeah.
So I remember that the UI document, which is the traditional way of using UI toolkit in a scene, it's not part of the subscene. So talk to me a little bit about how you decided to bridge those two worlds between UI toolkit and dots.
Yeah, definitely. So yeah, again, the UI document, you'll see that I have kind of a UI controller script over in the inspector. Again, this is kind of what's used to say, reference everything on the UI side. And again, because we have kind of all these UI toolkits that don't have the ECS equivalent of it, this all needs to live outside of the subscene here. So yeah, we can go ahead into the UI controller here.
Before we do that, let me just stop playing for a second. And I want to compare UI toolkit to the traditional UI system.
Yeah, for sure. Yeah.
So just so
to
people
kind of
who
show
are
how
a
that's
bit
all set up.
new.
Yeah.
I've had this scene running for a while. I don't know. It's getting a little confused now. There we go. So usually in Unity, if you've been doing UI for the last 5 or so years, you'd right click in the hierarchy and come down and use this UI system. So when you're comparing the Unity UI system to the UI toolkit system, one of the dead giveaways you're using Unity UI is if there's a canvas involved. So if you're familiar with using Canvas, that's the Unity UI system. Also, each of the elements that you add within the canvas, they sit on a game object. So if I was to add a button or an image, they would add additional game objects to the scene. So that's the traditional system. The new one that we're talking about here is the UI toolkit. And it is based on one game object in the scene, which holds a UI document. And then the rest of all the different UI controls sit somewhere else. So if I was to take this UI document here and see that we've got the reference to the panel settings, which is kind of like the canvas scaler in the old system. And then we have this visual tree asset. This is kind of like HTML coming from the traditional web world. So if I open that up, Unity opens up the UI builder window. Let me make it nice and big. And what it does here is it gives you a chance. Now, while this UI looks kind of like the Unity editor itself, we're now looking at just one window, which is UI builder. It has some kind of familiar layout, like it has a hierarchy. Then if we click on something, it has the inspector on the right, but this isn't the Unity editor. This is one window of the Unity editor. So here, Johnny was able to lay out the different elements that he wants. And no matter how many you add there, they all kind of get boiled down into that one game object in the scene. So with that piece of orientation, we'll pop back and go into this custom dots related script that you've got here.
Yep.
For UI controller. So what would you like to talk about here?
Yeah. So again, there's kind of a lot in here. But yeah, basically what we're kind of doing here is actually, we can kind of just scroll down a little bit. So yeah, the first thing that I'm kind of doing is, I believe it's in the, on enable here. First thing that I'm doing is basically just getting reference to all the different UI elements. So, every kind of little UI element and button on the screen, I want to have a reference to those so I can say, add functionality to kind of, listen to when one of the buttons are clicked, or if I want to say update the score label, I kind of just have references to those. So first thing that I'm doing here is basically just getting references to all those things there. That's, seems pretty standard for kind of UI toolkit here. Next thing that I want to point out, you'll see that on line 50, I'm setting the ECS world. So basically, we can access this by doing a world.default game object injection world. Kind of a long name, but it's basically just the kind of, it's a way that we can reference the kind of default ECS world. Through there, we can kind of access the entity manager for that world, which allows us to kind of do entity operations. Again, if we wanted to say set entity data, we could use that as well. But also when we have the ECS world, we can say reference systems which are within that world. So you'll see that I'm first getting a reference to the pickup count UI system. So this is just kind of the system that I've created that actually kind of increments the, say, internal data component of how many pickups the player has picked up. So there's kind of that internal data representation that's kind of continually incrementing. But again, it's not directly updating anything on the front end UI. So this is again kind of listening for this event. So you see that the next line down, I have this event that's on that system called the on increment pickup count, and then we're basically just assigning this to the set pickup count. So if you say go down to that set pickup count method, then you'll see that basically all we're doing is we're just updating our score label to say, what is the current score. So we're saying, pickup counter dot current count / pickup counter dot target count. So again, this say event that I'm invoking from the ECS side is actually passing over this whole pickup counter data component. And that pickup counter data component, again, is just kind of a regular ECS data component. It has two fields on it, one for the current pickup count and one for the target pickup count, which is kind of the target that you want to get to complete the game.
Very cool. Let me recap a little bit of what I'm learning here.
Yeah.
So most of this class that we're looking at is not dots related. So we're using a mono behavior here, doing pretty traditional mono behavior stuff. Then here I see there's a dragged reference into this mono behavior of the subscene. And then the references that you went over, this kind of stuff here, is really the dots related stuff. So here we have a non-dots class that kind of reaches into the dots world and listens to some certain events.
Exactly, yeah.
And then down here, I see one case where, just move it up a little bit. One case where we're actually changing something inside that world, and that's when you toggle the pause. So can you talk a little bit about that part?
Yeah, the toggling of the pause is actually kind of like an interesting thing that I figured out just kind of on my own kind of recently, actually. So basically, would we say define these systems on the ECS side? They're, again, like I mentioned, they're kind of like automatically created and they start automatically running within Unity. Now, these are actually kind of put into different groups, and there's actually 3 kind of main groups that these systems can fall into. So there's the initialization system group, which is basically just kind of for, initialization logic. Typically most systems that we create are not going to go in there. Next, we have the simulation system group, and this is kind of where like all of our main gameplay systems happen, where we're, kind of moving things around, we're calculating different values, and that's just kind of like the default where systems are going to be placed if we don't say, have this system go to a specific group. So again, that's the simulation system group. And then finally, there's the presentation system group. And this is what kind of handles, all the rendering and, kind of presentation things. So basically what I'm doing here for toggling the pause is I'm kind of doing a little bit of a hack, but it seems to work out pretty well, is I'm actually getting a reference to that simulation system group, and then I'm just disabling that entire group. And what that does is it just disables all our, gameplay simulation systems. So, we still kind of have our initialization system running. So if there was anything in there that's like, kind of doing any initialization, we're still kind of reading player input and things like that in there. And the presentation group is still running. So it's still kind of rendering everything. But the key thing is it actually just not simulating anything in that simulation system group. So that basically stops any of the custom systems that we created, and it stops any of the systems that Unity has by default, such as, the physics systems and things like that.
That's super cool. That first initialization group that you mentioned, does that run just once, kind of like start or awake, and then it doesn't have the equivalent of update?
Good question. So those three groups that I mentioned, those are kind of always running every single frame of the player loop. So that's, we kind of have the player loop that runs every frame, and then kind of going down into each of those, there's the initialization, simulation, and presentation.
So it happens, it's like initializing per frame.
Correct, yeah.
Okay, I thought it was initializing like per game session, just once. Okay, that's super cool. Anything else you want to take a look at here?
No, I think that's kind of the main gist of the UI system. Again, there's, kind of some more complexity when it comes into like, restarting scenes and things like that, but I don't think we necessarily need to get into all that right now.
Yeah, that sounds good. One last thing I'd like to see is how you take the input from the input system.
Yeah, for sure. So actually, I'm doing that through a system, and kind of speaking of the initialization system, it is kind of, I have it running in that system. So yeah, if you expand that input folder, so we see that I have the, let's go ahead and just go to the move, or the player move input first.
This one
that
here.
bottom one. Yeah, and I can just kind of show you, this is the, say, data component that we're going to be writing to. You'll see that it's just kind of, again, regular iComponentData. It has a public float2 value. So this float2 value it's similar to a vector2. It's, basically the same thing. But this is from the new unity.mathematics library, which I kind of mentioned earlier. Again, this mathematics library just works really well with the burst compiler. It is, a completely unmanaged type and everything like that. So when we're kind of using, say, we want like a vector2 or a float3 or a vector3, anything like that, we use the kind of unity.mathematics more efficient equivalents, which are the float2, float3, and so on.
What does it mean to be a non-managed type?
So the thing with unmanaged types is these kind of work well with the burst compiler, just because we know basically how big this data component is. Like, it doesn't have any kind of like references to other places in memory. Like, we know the exact size of what that data component is. So that kind of goes into some of the efficiencies of the job system and burst compiler and all that.
So is it fair to say that like data types and other elements within the dots world, it's like a more strict thing? There's more strictness to it, but with that strictness, the compiler can make assumptions to make it run even faster.
Yeah, absolutely. So yeah, there are, a lot of restrictions. There are ways that we can still use managed types. But in those cases, we won't get the same advantages from the job system and burst compiler that we could.
Very cool. All right, what should we look at next?
Yeah, so we'll go ahead and go into the, so I can just show you the player input authoring just real quick, just because that's a super quick one. Again, this is just something that we're saying adding to a component within our subscene. You see that I don't have anything inside the input authoring mono behavior. There's no like, fields that we need to set or anything like that. You see that all we're doing is just on this entity, we're just adding that player move input, just so we can kind of have like a dedicated entity for kind of handling our input.
I don't remember this, but this class definition is within the authoring class definition. Was that the same as the last one we saw?
So yeah, it wasn't. There's no it can be a nested class, but it doesn't. It can be outside of it. Yeah, as long as we just kind of have that reference to it through the Baker, where we're passing in the player input authoring type. As long as we have that kind of reference in there, that's all we really need.
And one thing that I'm thinking of is this true that the nice thing about using the authoring Baker workflow is because we can have it sitting on a game object in our scene, like we traditionally think about Unity. Our hierarchy has a thing in it, and here's code that's on that thing. So anytime we want to adopt that traditional old workflow, that's where this authoring Baker really makes sense.
Yeah, absolutely. And it, allows us to, if we're working with designers who don't really have any familiarity with coding at all, and they're, definitely not like getting into ECS coding, we can have these, nice bakers, and we can create, different custom interfaces or custom inspectors like we would for regular mono behaviors, to, just really kind of, empower the people in our project to, create different behaviors in our game.
Cool. All right, what should we look at next?
Yeah, so we'll go ahead and look at the get player input system here.
All
right. So yeah, you'll see that kind of what I'm doing here is you'll see this update in group type of initialization system group. So again, like I mentioned, that we kind of have these 3 separate groups in our main player loop here. So I'm just saying, let's go ahead and put this get player input system into that initialization system. So we can kind of guarantee that it's running before any of our systems in the simulation system. Furthermore, I'm just setting this order last flag equal to true. That's just kind of a personal preference. I just, like to have Unity run all its stuff first, and then I just have my, get player input running at the end of that initialization system.
Cool.
So you'll notice that this system is a little bit different than the one that we looked at before. You'll see that this is, again, it's a public partial, because it is taking advantage of code generation that Unity does to make this more efficient. You see that this is a class and not a struct, and that the type that we're inheriting from, it's not an I system, it's a system base. The system base it works kind of similar to an I system. It has kind of its own life cycle functions. But again, you'll notice that it is a class. The main difference is that with the system base, we can use managed types within the system. Whereas with the I system, we're a little bit more restricted. But again, the benefits of that are we can actually burst compile the code that runs in I systems. So the I systems are a little bit more efficient, but the system base kind of give us flexibility to use more existing Unity features.
Very cool.
Yep. So basically what we're doing here is we have a reference to our custom input assets. I don't think we necessarily went into what the input asset is, but it's part of the new input system where we can kind of define what buttons a player can kind of do to access different features. There is an option on
that
this.
real quick here.
Yeah.
So if I go back into the project, let it reload there. I'll click and open that up just so we can see how that looks and where can I find it in the project here.
So that is inputs, and then that one there.
Yeah. So just like we talked about how in this dots demo, we're using UI Toolkit, and that is a newer, greater way to do UI than the Unity UI solution. Unity has 2 competing input systems as well, with confusingly similar names. So there was the Unity Input Manager that was around from the very early days until several years ago. And since several years ago, the new cool thing is the input system. So that's what we're looking at here. And one of the cool aspects of the input system is that you get to design how the user will interact with your game with a really nice, flexible solution. So we can see that this version that Johnny did allows for input from the WASD keys or the arrow keys, and then passes that through as a vector too. Anything else you want to say about this?
So nothing on this, so we can close out
Okay.
of there. There is one other thing that we do need to do in Unity. So over in the Spectre, you'll see that there is this option for generate C# class. So you see that I have that box check marked. And then actually over in that kind of input folder, you'll see that it actually generates this RollABall input C# script. So that's actually what we're going to be referencing from our input system. So that kind of generated C# script.
Very cool. So let's go back into here and keep going.
Yep. So yeah, basically what I'm doing here is, first thing that we need to do is actually instantiate an instance of that basically kind of RollABall input type that we created there. Again, I'm just kind of storing a reference to that in a field of this system here. So we're just creating a new instance of that and enabling it, which allows us to basically read input here. So there are a couple different ways that we can read input from the new input system. In this case, what I'm doing is I'm just continuously reading what that input value is. For things like player movement, it kind of makes sense for me to just continuously read that value from the player input, as opposed to, say, listening to events when that value changes. Just because player move input, it's something that we're going to be updating pretty consistently throughout the duration of our game. So it makes sense to just constantly read that. So you'll see that basically what I'm doing here is just kind of accessing that vector 2 that we defined in the player input actions assets. And I'm currently just writing that to a vector 2. And then you'll see that what I'm doing here down in the on update is I'm using, again, that system API to do a set singleton, because then, again, we know that there's only one of those player move input data components in the ECS world. So this is kind of considered a singleton component. And you'll see that I'm creating a new player move input. And again, just setting that value. Remember, that is a float 2 value. I'm setting that to the current player input, and there is kind of an implicit conversion from the vector 2 to the float 2. So that's how we can just kind of pass that in there. And again, that's just kind of how I'm setting that player move input. And again, this happens in that initialization system. So now we can have any number of systems in the simulation system reference that player move input to see what the current move input value is. So we're not like having to, actually read input from the input actions a bunch of different times. We can just kind of reference that data component that we're continuously keeping updated.
I see. So you're doing some work here to put this player move input like into the stream, and then anybody who wants to can grab at that.
Yeah, absolutely.
Very cool. That's it. And now you mentioned that you can it implicitly changes the vector 2 to a float 2.
Mm-hmm.
Is that something that you need to think about or kind of get good at, knowing which data types convert to which and how to manage that change?
It hasn't really been that difficult for myself and some of the other people that I've kind of worked with to kind of wrap their heads around. Like that's a pretty easy one. There are some little quirks with the math library, like for example, like if you want to say like look at the magnitude of a float 3, instead of it being like math.magnitude, you say math.length. So it's like just some slight differences in the API like that you kind of need to familiarize yourself with.
Cool. Super cool. Anything else you want to look at with the code?
I guess real quickly, maybe I can just kind of point out how I'm kind of rotating the pickups, because I know I'm doing that one in a little bit of a different way. That system is just a little bit different. So I just might want to point that out real quick.
Sure.
So if we could go to the pickups, looking for the rotate pickup system down at the bottom. So this one is a little bit different because what I'm doing is the work itself isn't actually being completed in the system itself. Rather, we're actually creating a job and we're scheduling that job to actually complete the work. So you'll see that the system is really super simple. All I'm doing is getting delta time and then just scheduling this job just by passing in that delta time to the job. And so you see that there's kind of some different options that we can do on the job. We can say do a .run, which would run it on the main thread. In this case, I'm doing a .schedule parallel, meaning it can basically schedule it to run on one of the worker threads, which is where we can kind of get into like some of the multi-threading aspects of the C# job system. And the schedule parallel will allow it to run in parallel with other instances of this job or other jobs that are maybe not writing to the same data components that this one is.
Now, I remember something that felt kind of similar with the player. And what you did in the player was did a for loop over it and made changes on the player's physics in a for loop. So how come here you decided to do it in a scheduled job instead of just doing it in line, or is that even possible?
Well, so the main reason that I did it for this particular example is to just kind of showcase a different method of doing this. The reason that I kind of chose to do this system this way is, if we're doing things on, larger numbers of entities, it makes sense for us to do a schedule parallel so that, rather than the, system just being able to iterate on, say, one of these pickups at a time, it can iterate on a bunch of different pickups depending on, how many worker threads we have available in our CPU. So it can kind of do all those in parallel. So, in this case, we're not really up to the point where we can actually kind of, parallelize, all the pickups just because we don't have that many of them. But, if we were to say have, hundreds of these pickups, now we could say apply this job again, all in parallel. So rather than, waiting for the main thread to rotate all the pickups, we can kind of, parallelize that out across all the threads on our system.
That makes total sense. So we only have 9 here, but you can imagine having many more than 9.
Exactly. Yeah.
Efficiency would make sense.
Yeah.
So then lastly, tell me about the job here that does the actual rotation.
Yep. So yeah, this is a special type of job. It's called an iJob entity. Basically, this is just kind of how we can define a job to run across a number of different entities. So you see that we don't need to do any kind of like for each. We're basically just kind of defining this job as if it were just operating on one single entity. And maybe just kind of like, some minor differences between this and the for each that we had previously. You'll see that I have this execute function. This is just kind of something required by that iJob entity interface. And then here's where we kind of define the different data components that we're kind of querying for and things of that nature. So we're basically looking for anything that has a local transform component, which is the kind of the transform component that we're going to be writing to, as well as the pickup rotation, which is just kind of where we're defining, which direction that it's rotating, like, which axis it's rotating on and how quickly it's rotating. And you'll see here that there's just, one line that we're doing here is where we're just setting the transform equal to a transform.rotate. And then we're basically kind of, calculating a rotation to rotate that by.
Very, very cool. That's awesome. Anything else you want to look at with the code?
No, I think those are, main kind of, high level overview about sort of all the major systems in the game. And again, if anyone wants to, they can kind of dive a little bit deeper into this. I have everything kind of commented out so you can kind of get a little bit more context about, what each of these components, authoring components and systems are all doing.
Yeah, well, we didn't look at everything. We did do a good overview. We looked at some of the input, some of the player. We looked at the component. We looked at the system, and some different use cases for how to update them. So I think we did a pretty good overview there.
Yeah, definitely.
I'll pop back here. I'm going to run the example one more time.
Yeah, you can see that the compilation takes a little bit longer, especially when we're using the burst compiler, because again, it's kind of taking our high-level C# language and compiling that all down into native assembly, which does take a little bit of time.
Very cool. All right, it's awesome. We'll pop back to the slides and we'll finish up here.
Sounds great to me.
So some learning resources. I mean, when this video goes up, we'll have links to both Johnny's additional resources as well as mine. I don't have any other videos or content specific to dots, but I've got lots of stuff about MVC, which we talked a bit about, and UI Toolkit. So you can take a look at my website there and see that. And particularly around MVC, I have a Udemy course, as well as a Udemy course on physics. Now, the physics course covers everything that is 2D and 3D and C# about physics. Doesn't do much about dots, but I do have one lesson at the very end which touches on dots using dots physics. But it's mostly a non-dots course there. So that's it for Johnny and I. We can each kind of just summarize how the talk was for us. I learned a lot from you about dots. It was really cool to see the latest, greatest version of dots as it is today, because I've played with dots a little bit over the last couple years. And I remember maybe 3 years ago making a simple game, and then 2 years ago trying to update it, and it just crashed because things had changed so dramatically, as I'm sure they have with that while it was in beta. So yeah, I guess in summary, we've taken a look at kind of why dots is interesting, because it's a powerful way for you to create more ambitious games, as you said. But there are some thoughts about how to integrate dots into a larger game project. Some systems inside Unity don't use dots yet, so you have to think about this hybrid approach, like you solved there with the input system and the UI toolkit, which was super cool. And then also, we didn't really talk about this use case, but maybe in a larger existing non-dots project, you've got lots of traditional game object stuff, but you want to optimize a particular system. So is it true you could also choose just have one area of your own code base be dots to take advantage of some of those benefits?
Yeah, totally. And even like I mentioned a little bit earlier in the talk, you still can use the job system and burst compiler to, optimize, specific parts of your existing application. But there are definitely a lot of cool things that you can do. I know there is one asset on the Unity asset store called Agents Navigation, which uses ECS to, kind of optimize for pathfinding and local avoidance and all these things. One really cool thing about it is you can use it with a purely game objects project or a purely ECS project. The way that it kind of handles the game objects project is, for all your kind of agents that are doing pathfinding, it actually creates an ECS entity just kind of, by itself on the back end. And that entity is kind of doing all the, complex pathfinding calculations, figuring out where it needs to move any given frame. And then it kind of synchronizes those results back with the front end game object. Now, your performance is not going to be as good as if you were just doing a purely ECS based approach, but it is still a way that you can really get a lot of the power of dots, with still using all your game objects for, most of your kind of front end logic.
That's awesome.
Yeah, totally.
So I started our talk today by saying, is now the right time to jump into dots? So for people who are interested to consider it, like, how do you see the choice of you're starting a new project and you're deciding, should I try and lean heavily on dots for this next one or not? Like, how does someone go about making that choice?
Yeah, that's a great question. I did put up a video recently on my channel where I kind of talk a little bit more about the specifics of, all the Unity dots packages and kind of maybe give a little bit more context about, if it's kind of right for your project. But I guess the kind of gist of it is, if your project has some, specific performance requirements, maybe you do want to make an ambitious game with a higher entity count, or you want to take advantage of netcode for entities, like you're making a competitive multiplayer game. or again, you kind of have some performance restrictions if you're using a lower powered device, if that's kind of, what you're targeting. And, maybe if you've done some prototyping and you're kind of running into some performance limitations pretty quickly, then I think at that point, it's, at least something worth considering. But again, maybe like you've seen in some of these kind of samples that we've pointed out, it's not necessarily the most beginner friendly thing. And like I mentioned, that it is very important to kind of have some fundamental understandings of, regular Unity programming, because you still are going to be needing to integrate with a lot of existing Unity features to, make a full complete project.
Yeah. I mean, since I started my Unity journey long before dots, it does feel different and maybe a bit challenging. So like anything new, like we discussed earlier, it's an investment. You have to put some time and energy into learning it enough before you really become powerful at it. But it does feel weird to me as someone new to Unity. Let's say if someone is watching or they're getting into Unity, that if you go into the dots world, now there's kind of two systems. You're bridging between the traditional world and the not, and you almost need to learn both systems.
Yeah,
you can't just learn the dots one. So I guess that's the growing pains of something being new. And Unity has been around for about 20 years, and this is the very first year that dots is 1.0, right?
Correct. Yeah.
So there's a lot of history of documentation and resources that you can find that, if you Google how to do something, you're probably going to find the non-dot solution. So that's an additional challenge to trying to doing more dots. But what do you see it being like in Unity 10 years from now? Will there still be a distinction between the two systems, or would your guess be that they become more similar, or what?
Yeah, I mean, obviously hard to predict the future, but I would say that I would think that, I think like you kind of mentioned earlier about, one of Unity's kind of initial intentions with dots is to kind of like really bring the power of dots to existing Unity features. So, maybe you are kind of using some Unity features that are really taking advantage of dots on the back end, but again, you don't necessarily realize that. So I think that is something that we may see of a little bit more. And just kind of, maybe Unity finding some ways where you kind of have an existing Unity project built out. And if there are some, ways that you want to kind of, optimize for, iterating across a large group of entities, that again, Unity can kind of do some of that stuff under the hood for you. And you as a developer, you don't necessarily need to worry about, creating an entity query and, scheduling a job against that entity query and all that.
Do you see the community, like the Unity Asset Store, for example? Do you see the community creating more tools to help the dots and non-dots world coexist? Or do developers who are working on dot stuff, they just lean into pure dot solutions?
That's a good question. There haven't been a whole lot of assets, like dot specific assets on the Unity Asset Store. Kind of like the one that I mentioned, the agents navigation one, that is kind of one that is, again, it's compatible with both game objects and entities. But that one is a little bit of a unique case. I think, kind of some of the other ones are maybe a little bit more either dot specific or just, don't have any regard to dots. That's kind of the majority of them. Is just like, they were built before dots was even a thing, or, even when it was in preview, they still weren't kind of integrating directly with it yet.
Yeah, I mean, my gut feeling is the gross majority of Unity users are not yet using dots. So it makes sense that the community assets would still reflect that traditional, balance. But as more teams start to use dots on more projects, we might see a shift there in the community that dots gets more served.
Yeah. I mean, dots is, it's definitely a very niche and specific thing, but there is a, very dedicated community who are, very passionate about it. They use it a lot. If you go ahead and look at the Unity forums, there's a lot of, really great people on there interacting all the time. Even in my Discord, which I have the link to it on the slide right here, a lot of really great people who are kind of into it, and they're, really, kind of into sharing some of their different learnings. And a lot of people are creating GitHub repositories to kind of make things easier and more convenient to do.
Super cool. Well, I think that's it for me. Is there anything else you want to say in summary?
No, that sounds great to me. Thank you so much for having me here today. I think this was a ton of fun, and I hope people learn some good things about dots. And maybe if they want to learn a little bit more about it, feel free to go ahead and check out my YouTube channel. Again, it's Turbo Makes Games. Most of the videos that I do on there are kind of related to dots. I do a lot of tutorials and just kind of other general news updates and project showcases and all sorts of fun things.
Awesome. Thanks very much, Johnny, for coming and for bringing all this awesome dots related stuff. And it was good to get to spend some time with you and talk about Unity. So thanks again.
Sweet. Thanks, Sam.
All right.